All right, here we have this series circuit with resistance and capacitance. What's the first thing that we need to do? First thing that we need to find. What's the first thing? First thing that we need to find is that capacitance. So we're going to go through this to find out what the capacitance is of this 88.5 micro, because it's got a mu, Farad. 88.5. That is, I'm going to just move this over 6 spaces. 1, 2, 3, 4, 5, 6 spaces. So this should be 0.0000885, okay? That's going to be our number. We're going to use this formula right here. X sub C, so we're going to find the impedance of this capacitor right here. X sub C equals 1 over 2 pi FC. 2 times pi, what's that, Maldonado? $6.2831.8-ish. Okay. Times the frequency. What's the frequency in this circuit? 60 hertz. Times this capacitance. 0.0000885. It equals, has this really low number. Now I'm going to do the 1 over x on here. Gives me 29.97. 29.97. Okay, looks like I fouled up just a little bit, but we're all right. We're going to call this 30. I was going to have this be a 3, 4, 5 triangle, but it looks like I'm going to have it be not quite that. So the capacitive reactance of this capacitor is 30 ohms, okay? What's the next thing I need to do? What's the next thing I need to do? I need to find out what this is, right? What the ohms, the total ohms of this circuit is. These are out of phase by 90 degrees. I have this. So I have 30 ohms and 30 ohms, okay? 30 ohms and 30 ohms. A squared plus B squared equals C squared. So 900 plus 900 is 1800. What's the square root of 1800? You guys shy? You just don't want to be on the video?
42.
42. So that 42 ohms, that's this ohms, right? 42 ohms. What's the next thing that I need to do? Well, I noticed that this plus this isn't that. That's because these are out of phase. This 42 ohms is right here. Okay? What's the next thing I need to do? Usually I'd ask Mr. Smith, but what? I'm going to find the amps. How do I find the amps? Volts divided by ohms. 480 divided by 42 is what? 11.4. And if I have 11.4 amps in one part of a series circuit, I have 11.4 amps in every part of the series circuit. Now what can I do with this, Mr. Mason? I need to find the voltage drop across each of these, okay? Does this number matter anymore?
No.
Not so much. So I'm trying to find the voltage drop. All I have to do is multiply my amps times my ohms. So 11.4 times 30. 11.4 times 30. 342. This one's going to be the same. Now 342 plus 342 does not equal 480 ohms. That's because they're out of phase, right? Let's go ahead and find our watts. Mr. Mason, how many watts do I have? Watts. 3,898.8. 3898.8, okay. Watts. Watts because it's going through this resistor. That's our true power. That's going to be our watts, our true power. How do I find our volt amps reactive? Since I've got the same amps and volts on this, this is also going to be the same answer for my volt amps reactive. It's, oops, 98.8. VARs, okay. And now how do I find out how many volt amps I have for my apparent power?
You got 5,472.
5,400 what? 72?
Yeah.
Volt amps. Now let's say I want to find my power factor. Power factor. It's the watts. What? Divided by volt amps. What's 3898.8 divided by 5472? Looks like it's 0.7125 or 71.25% power factor. I'll put PF. Doesn't stand for price fister. Okay. One other thing we need to find, let's find that phase angle. I like to use the tangent for the phase angle. So I'm going to use 30 divided by 30, or the opposite divided by the adjacent. Okay, oh, sorry, 30 divided by 30, my bad. I think that's 1, isn't it? I'm gonna check it out. Oh yeah, it's 1. And then I'm gonna do the arctangent of that. It says it's a 45-degree angle. So this phase angle on here is gonna be 45 degrees. Much too cool to be working outside without a jacket on. Anybody have any questions on any part of this? Easy peasy, lemon squeezy?
Yeah.
All right.